Okay, so welcome to a demo session on the subject Theory of Computation. Few of you might already know me. My name is Aditya Agrawal. I will be your instructor for this course. I am an MS scholar from IIT Madras. I worked in the space of high performance computing, architectures, and compilers. I was working as a data scientist before, and I hold a BTech from KT University. So we'll talk about TOC a little bit about TOC and why we need to study TOC with a simple example. Few of you guys might have a fascination or might like this subject, which is C programming or any programming language. So, have you ever declared a variable in C? Will be the first question I want to ask you guys. Have you ever declared a variable in C? Yes. So, when you write a C program, you write something like um, int, maybe let's say IGC 123 equal to 5. This is one of the ways by which you declare a variable in C programming. You could this is similar in case of C++ and other languages like Java. Now, if you guys know, the name of a variable often has some restrictions, right? You can't just name any variable whatever you want to. For example, let's say you are renaming your variable like this. You are declaring a variable like this. Okay, is this a valid variable name? Anyone who knows? No,
No, sir.
because this variable name starts with a digit, and digits are not, you are not allowed to use a digit as the first letter in a variable name. A variable name should only start with a, anyone who wants to volunteer in answering this, should start with a letter, only letter, that's it, nothing else. Good. Underscore as well, letter or underscore. Good, 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 good guys, good. So this is a valid variable name. This is not a valid variable name. This is a valid variable name, right? This is a valid variable name. But okay, how about this one? Is this a valid variable name? Anyone who wants to volunteer in answering it? This one is valid. How about the last one? Valid? Invalid? Okay. This is also valid. Okay. Now, so typically these are some rules that are present when you want to define a variable in C. A variable must contain alphabets, digits, and underscore. You can't have any other characters. For example, you can't have special characters or spaces. The variable name must start with an alphabet or an underscore, as we saw in the previous slide. It cannot start with a digit, right? And you can't use a white space in a variable name. You can't declare a variable like int maybe Shrikant space t, right? You can't do that because you can't place a space in a variable name. And the variable name must not be any keyword that we know. If, else, for, while, these are some of the keywords in C. You can't have a variable name with that word. Okay. Now, why did I talk about this thing, right? I'm talking about TOC, but this looks like a C lecture. No, this is nothing but TOC. How? If I ask you this question, imagine you are a programmer and you have declared a variable. Okay, let's say I declared a variable int IGC 123. If I tell you can eyeball this and tell me that, yeah, this is a valid form of variable declaration because it follows the rules of what I had discussed in the previous slide. How can the computer do that? what will the computer do, or how should you instruct the computer that, hey, this is a valid variable name, while if I start something with a digit or if I do some mistake, that is not a very valid variable name, right? How can you tell the computer that something is a valid variable name and something is not valid? So typically you guys might think some solutions that is very good in this case, but let's look at few ways how you can do it, right? Maitri, I think, knows a bit about TOC. She has given a very good answer. Define the rules using regex. Very good, Maitri. We'll look into it in the classes in TOC. But my motivation behind this is, if you guys don't know about TOC at all today, okay, since you're learning TOC, so it's very much okay, and I am here for that as well. You would think that let's store all the variables. We'll check. So Sham Sundar is saying we'll check if the data type and the value are matching. Okay, okay. So, Sham Sundar, just to clarify, you mean this is also valid, right? Because the data type and value is valid, so this is valid, right? Sham Sundar?
Yes, sir.
But this is invalid. You're starting with 1. That is not allowed. Okay. So, no problem. The thing is, you have to only focus on this one. I'm trying to say whether, okay, this box, the thing that I've written in the box, for example, in this case, the variable name, does it follow a restriction? If let's say I write this, um, yeah, let's say instead of 5, okay, wait a second. Let's say I write something like this: int 1 IGC 3 equal to maybe Aditya, my name. Okay, this is invalid in two ways, right, Shamsundar? One is your whatever you are saying, that's absolutely perfect here, because you check the data type, it's an integer, but you check the value, it's a string or a set of characters. A set of characters is not an integer, so this is not allowed. As well as this variable name is also not allowed. Now this part of checking is done by something called syntax analyzer that we will study when we look at compilers. Compilers is, that's why, one of the follow-up subjects of TOC, because there is lot of link between the two. This is done by the syntax analyzer, while this one is done by something called lexical analyzer. And from where these terms come up, we'll go into it. I just wanted to get you excited. These terms we will learn more in when we start talking about compilers. Okay, chalo. Okay, so I was talking about the problem and now some solutions. Let's say one solution you find out that, let me store all the valid variable names, whatever variable names that are valid, let me store them all in a database. And when the user has inputted a variable or declared a variable with a variable name, I will check the database and find if it is valid. Does it solve my problem? It does, right? I have a set of variable names in a database. You declare, let's say, IGC123. I check if IGC123 is in the database. And in case it is, I say it's valid. Is there any issue with this? Can you think of an issue with this? Or do you think this is the solution? If this is the solution, certainly TOC is not required, but that's the hint. Pranav is saying a perfect point. There are too many variable names that you can store. Perfect. And for storing them also, do you need some space also for storing them? Let's say I told you that, let's take this very simple, right? I told you I have the entire time to write all the variable names, and I will actually do that. Okay. am I wasting space here also? Because I'm trying to store all the variable names in a database. The database takes some space, and if it takes some space, I'm wasting unnecessary space. Other thing is, if you have a set of variable names, like let's say 1 million variable names, for example, won't your search complexity will be high as well? What do you think? Yes, because let's say I have 10 million, let's say I have 100 million, let's say I have more than that. You will have to search through each of them. You might argue that, hey, let's use binary search. Fine, use it. But that is one of the ways to do it. But what if, let's say, my strings are only 5 length? Then you would go through each variable name and find out that, hey, this is the variable, right? So it's better. So we need to find something better here. And certainly computers are not made to work this way. How computers work is, that's the exciting part, and that we will learn in TOC. In this part, in today's lecture, I will draw a very simple machine that we can use to find out whether a variable name is valid or not. Okay. So we need to think about some other solution. Other solution could be, let's say, if I talk about it again in a very abstract manner, what I'm trying to say is, why don't we have a machine? Okay, this is my machine. So a machine should take as some input and give some output. And what do you want to do? We want to input a variable name because we want to find whether it's valid or not. And you guys understood what do I mean by valid, right, by now? Or should I explain it again? What do I mean by valid? Valid means if it follows those restrictions or rules that are imposed. What are those rules? I hope you remember. It should start with a letter or digit. It should start with a letter or underscore. It would contain any combinations of letters or digits, and no space is allowed. Okay? Okay. So the input is nothing but a variable name. It will go into the machine, and the machine will say yes if the string is valid or the variable name is valid, or it will say no. If I can build this machine, my problem is solved, right? You guys with me till here? Problem is set now. Okay, awesome guys, awesome. Okay, now our goal is to create this machine, right? Our goal is to find out how we can make this machine, right? It's just a very abstract thing. I have said that, oh, we have a machine. Oh, how do you create it? You might ask me. Well, that's a valid question, right? So before we create a machine, right, I'm trying to denote some things by some symbols. What do I mean by it is, let's take the set of all alphabets that exist in the English alphabet, all the letters that exist in the English alphabet, from small a to small z, from capital A to capital Z, in a variable which I call L. L is nothing but another variable which holds all the symbols corresponding to A, all the letters A, small a to small z, capital A to capital Z. Okay? Similarly, let's denote a digit, any digit, and digits are how many digits? We have 10 digits in the decimal number system from 0 to 9. So the digit D, I am denoting it by letter D, could be either 0 or 1 or 2 or 3, 4, 5, 6, 7, 8 or 9. Any other digit can I have? No. Similarly, letter also, can I have any other letter? No. So this is just nothing but a shorthand notation that I'm using for a digit and a letter respectively. And I am denoting underscore by a symbol which I called US, underscore, okay, US, right? And the space character is denoted by this big triangular basis which I call space. Okay, does anyone have any doubt in this part? What is a why is it called a letter? What is a digit? Why am I doing it? I will explain it later, but it's clear, right? What do I mean by L? L could be any letter from small a to small z or capital A to capital Z. Any digit D could be, any digit is denoted by small d, and D could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Underscore will be denoted by US, while space will be denoted by space in angular braces. Okay. Okay. Now, typically, you might also think now that how do I try to maybe, first of all, the computer has to read this string, right? It has to read this string and find out that, hey, yeah, this is valid while this is invalid. What do I mean by it is, this variable name is valid, right? IGC123 is valid. So let's write IGC123. Okay, let's bring that part out. Int and 5 we will look at it later, but let's bring the variable name part out, which is IGC123. Let me denote a arrow which I call the pointer. Okay, I'm trying to read this string character by character. Okay, and when the pointer is at the leftmost side, which means I haven't read a single character till now. Understood? When the pointer, I've introduced something, an arrow, which says how many characters have I read, or which character am I currently reading. When it is on the leftmost side of the string or the variable name, that means I haven't read any character. Okay. So when I move this pointer to the right, let's say the pointer comes here, then I am reading the first character, which is I. Then I move the pointer ahead. I move it to the, okay, yeah, till here, to point it here, then here, and so on. And once I reach this point, which is this point, that means I am at the rightmost end and I have read the entire set of strings. Okay, understood what is a pointer? Pointer first is on the left side, which means I haven't read anything. I will move the pointer one by one on the right to read each character. And once the pointer reaches the end, that means I have finished my reading of the string. Okay. So if I ask you guys this question, right? Let's say my pointer is here. Okay. If I move the pointer a bit ahead, let's say I move it here, and I see a digit. Let's say here, instead of I see a digit. Can I say that that whatever is read after that, whatever is read, I don't care, because the variable name is invalid, because my first letter is a digit. Can I say that? Yes. Keyword we will check it later, Shrikant. Very good question. Keyword we'll check it later. Just ignore the keyword part. Look at the other 3 points. Okay, that's a bit more complex finite state machine. If I draw it now, it might be a nightmare. So we'll look at it when we start studying it. But ignore the keyword part. If let's say it is starting from 1, okay, irrespective of any letters after that 1, it is a invalid string, right? Okay. So you guys understood what I'm trying to do, right? And then in this case, it's an I. So it's okay. It's okay. It's allowed, right? I go ahead. My pointer goes ahead. Now my pointer is at a letter called G. G is allowed? Yeah, very much allowed. Then my pointer goes to a letter called C. Yeah. Is C allowed? It is allowed very much. It's a character, right? And then it goes to A1. My machine say it's invalid. Should my machine say it's invalid? First question. No, because 1 is appearing after the variable, after you have read the first character. Then I go to the next character. Then I go to the next character. Then I come here and my machine will say that, hey, I have read whatever I want to read. Now I need to take the decision. Either it's a accept or a reject. Okay. Now, acha. Now you might be wondering, if I write here ADITYA equal to let's say Aditya only. I haven't finished reading strings, right? I am here. So how am I telling that I have finished? I haven't finished, right? Well, I haven't read Aditya. Then how can I say? You might say valid question. Is there a point reading that? Pranav, very good. Because we have read a space character, whatever I read after that doesn't matter. It's invalid. If it's A, B, C, D, 1, 2, 3, 4, doesn't matter. Okay? Now, whatever I said now in terms of pointers and all, right, I will do that in terms of a machine, which I call the finite state machine. Why do I call it finite state? Hold on. We'll look into it everything. Okay. Till now, I hope this pointer example is clear. Now let me bring the pointer back to where I was. Now, pointer when it is here, I call it a state. This is the state of the pointer. It is at a point where I haven't read anything. I haven't read anything. So I will denote that as a circle and I call it my initial state. Wait, I will name it something else. I will call it S0. This says I haven't yet read anything. Okay? Okay. Okay. Now let me recall back what you said in the last slide. We had something called a L, which denotes all the letters from small letters and capital letters. We had something called a D, which denotes the digits from 0 to 9. And we had something called a underscore denoted by US. And we had something called a space denoted by this angular basis space. Okay, good, cool. When I am at the leftmost side of the pointer, I denote it by a state. Let's say I go to a state S1. Let's say, okay. How can I go to that state? If my letter that I'm currently trying to read, which is this one, if it is a letter or it is a underscore, then I can go to a state called S1. Okay. From S1, I can read any number. Wait a second. Yeah, I can read any number of letters or underscores or digits. Okay. Then my string will be accepted. So I will denote it by something called a final state. A final state is denoted by two concentric circles, which means this if my machine is currently at this position, then I can say that my string is accepted. How? Look at this example that I have written here. IGC 123 and my pointer is on the left. I read the first character. Will my finite state machine advance to S1? Yes. Why? Because that's what I said. From S0, if you find a letter or an underscore, but in this case it's a letter, you go to a state called S1. So I'm at S1 now. Okay. Then the next letter character I have to deal with is G. G is fine, sure. G is also a letter. So I will come back to S1. Okay, because It's a valid thing, right? Can you also say that I is a valid variable name? Yes or no? You guys have used I a lot of times, I guess. I hope you mean where you used it in for loops for int I equal to 0. Every time you have used int I. So I is a very valid variable name. Is I accepted by this machine? Yes. Why? Because if my pointer is here, if I read the first character, which is an I advance to a final state, which is S1. So if I advance, if I stop, if my input stops at a final state, I can say that that string is valid. Okay. Is IG a valid variable name? Yes or no? Yes. Yes. Very much. It's a I. It's a G. Finished. So will this machine accept it? First, try to understand what is the machine, right? You look at the pointer, which is just before the I, which is S0. The first character that I'm trying to read is a I. I is a letter, it's an L, right? So I go to S1. But I haven't finished reading my entire string, so I can't declare that it's valid, even if I'm in a final state, right? So what will I do is I will read G. If I read G, you see it's also a letter and it falls to the same state as S1. And once I complete reading the string, hmm, once I complete reading the string, then I fall in a final state, and that's why I can say that the variable is valid. Now you might ask, hey, this should accept all the strings. Okay, let's take a counter example. Let's take the string um, 1, 2. I will not write here. Maybe I'll write. mm, yeah, maybe I'll write here. That's good. 1, 2, 3, IGC. This is an invalid variable name. Yes, everyone with me in this? This is not valid. Which is the first character that I'm trying to read if you talk to me in symbols? L, D, US, or space? It's a D because 1 is a D, right? 1 is a digit, it's not a letter, right? So from S0, where should I go? This machine says from S0, which is the initial state, I can go to S1 only if it starts with a letter or an underscore. But if it starts with a digit, it remains at S0. Sure. Okay. चलो ठीक है. Let's take this string. Okay. Is it an invalid string? Will your machine accept it? You look at 1, which is a digit. You stay back at S0. Okay. You guys are saying, okay, let me say this is the right one. Let's say, okay. Okay. I read 1, I am in S0. I read I go to S1. I read G, I stay in S1. I read C, I stay in S1. So I ended up in a final state. I should accept it. My machine is saying it's valid, right? So what you should do here is, if it is a digit, then you go to another state. Let's call it S2. Sahil, very good. So when if it's a digit, it goes to S2, and when I am in S2, and if I read any string here, any string, any set of letters or underscore or digits, anything, I don't care. I will keep on staying in this state. Could be any set of digits or letters or underscore or even space. Okay, could be anything. I don't care because my first letter is a digit. After that, whatever comes, I don't care. It's not my business. It's not. I have rejected that string. How will I reject it? If you look carefully at the machine, once you are in S2, can you go out of it? Can you go out of S2 using any input? I will give you a digit, I will give you a letter, I will give you an underscore, I will give you a space. Can you go out of S2? No. You have fall in a trap, or you are fall in something called a dead state. That's what Sahil is saying. Okay. Now, this is the final finite state machine, or a simplified finite state machine, that will accept any string which follows those restrictions. Okay. Now, you want me to run this machine on an example string? So let's run it on some example strings for you to gain more clarity. Let's say this is the string. Okay. Second. Yeah. IGC 123 and it starts with an underscore. Okay. My pointer is currently pointing just left of the underscore, which means I am in S0. Once I read this underscore, which state will I go to? Anyone? Rohit is saying S2, while Shrikant is saying S1. Everyone is saying S1. Sorry, S1. Okay, yeah, good. So if it is an underscore, it's an underscore. You go to S1. Okay, fine. Then you look at I. I is a letter. You will stay in which state? You will stay in which state? Back again in S1. If you read G, back again in S1. Read C in S1. Read 1, then will you go to S2? No, because you are in S1. You are not in S0. Okay, good. Good, guys. Everyone is understanding. That's very good. If you read 2, you stay in S1. If you read 3, you stay in S1. Have you read the entire string? Have you read the entire string? Yes, good. So now you might be asking me this question also, which is a valid question to ask. How do I say that I have read the entire string? It's just a pointer, it doesn't know anything, right? It could be a space. I could write IGC space 123, which is invalid, which I am not written in this diagram. But this string also, there's a space after 3. You can say that's a blank, right? It should reject it, right? Then how is the machine trying to understand? So this is a typical more in compilers. How will it use? Yeah, you will use a delimiter. In this case, what compilers do it, they add something called a dollar. Dollar denotes you have read the entire string. Okay, if the pointer sees there is a dollar, it means I have read the entire string, because dollar is not allowed in a variable name. You can have only underscores. Okay, this is some compiler knowledge, but that's okay. Okay, now as I said, from S0, I haven't put any state for space. Where do you think I should go? S1 or S2? I3 says S2. Let me give you a small hint. My machine will only be accepted, only start reading the string once it is at the just before the first character. That's the hint. If it is just before the first character, I will trigger my machine. Now can you answer? Heard the hint, right? The hint is just before the first character, that's when my machine will start executing. If the first character is a space, S0, Nilesh is saying. Okay, okay, good. So let's say I have something like this. This typically doesn't happen that much, but just in case if it does, if you build a machine like this, which is maybe possible, you have some set of spaces, right? That is what my 3 is saying. Very good thought. And you have written something like IGC 123. These are spaces, okay? These are not underscores. Sorry, these are spaces. If my pointer is here and you have written, let's say, space IGC123, you can check out in C. This is valid. This is not invalid, because why? We will again look in compilers, because we will try to remove the white spaces in compilers, but we are not studying compilers today. We are studying TOC. So you will stay in S0. Okay, just a second. Yeah. Okay, you will stay in S0. Okay. Okay. How about S1? If I read a space, S1 is also not defined, right? If I read a space, well, what should the machine do? Stay in S1. Okay. Anyone else? Accepted. Okay. Okay. Let's say my variable name is IGC space 123. What will you do? Will you accept it? Int IGC space 123 equal to 5. Which is the dead state? Sahil. Pranav, why are you thinking S3? To understand the thought process. Will you accept it first of all? Let's say I write int IGC space 123. Will you accept it? Is that allowed in C? C will cry saying, what is this? Interesting. Okay. But again, that's why I'm saying I'm not teaching compilers today. You have a string called IGC space 123. Okay. You have this string in full. IGC space 123. There is a dollar after the 3, which says I have read, which gives the end of character delimiter. Okay. So IGC space 123 is not allowed in C. That is why if you run this machine, I is allowed, you go to S1. G is allowed, you go to S1. C is allowed, you go to S1. But if you see a space, you must come to S2. Okay. Think of it this way. I am writing this string int IGC space. This is space, okay? 123 equal to 5. This is a lexical error. It's not a syntax error, first of all, because the variable name is invalid. That's what you will get. You can check it when you write a C program and check it. Okay. Now, if you look clearly at this machine, right? Um, this machine from any state, given any symbol, could be letter or digit or underscore or space, you are having one transition meaning from one state you are going to some other state. You are having a transition for each symbol that I have defined, in this case LD, US and space, from each state. Yes or no? Am I missing any symbol? Hmm? Am I missing? From S0, I have a transition when I see L. I have a transition when I see D. I have a transition when I see underscore, and similarly space. From S1, I have the same. From S2 also, I think I have the same. Am I missing anything? No, right? This machine is called DFA. What is DFA? Deterministic finite automata, which means from each state, it is very deterministic that given any input possible in that set of symbols that I've given, I will always land to some state. Okay. So this is the machine that I was trying to build. This is the state diagram. This is called a finite state machine. Why finite? Because there are three states. There are limited number of states. Why state? Because there is states, right? And why machine? Because this is a way by which you can, this machine, if you run it on a string or a symbol or on a variable name in our case, you will be able to tell me whether you land in a accepted state or a dead state, so that you can say it is invalid. Okay. Some optimizations you can also do here, right? Some optimizations you can also do here. What if you tell me now, tell me that, let's say that you might think that, why do I have a dead state? Let's say that if I can transition, okay, if I can transition, sorry, if I can transition, if I have a transition, let's say what I want to say, if I have a transition, which means if I have a letter from S0, if I have a letter or underscore or a space, then I go to S1. But if there does not exist any transitions, can I say that I have rejected it? Because the machine doesn't know where I should go. This is more like the machine saying, okay, you give me this string, give me this pattern, I will accept it. But if you give me any other pattern, I'm sorry, I can't do anything. And when the machine says, I sorry, I can't do anything, I can say that the string is invalid. How about this? Understood what I'm trying to say? My rationale behind saying this. The machine is saying, see, from I know how to go from S0 to S1. You give me a space, give me a letter or an underscore. But if you give me a digit when I am in S0, S0 is saying that if you give me a digit, I don't know where should I go. There is no transition. So I will just halt. The machine will say, hey, sorry, I can't do anything what you were saying. So I can say that this string will be invalid. Similarly, from S1, if I read a space, S1 knows that, hey, from if I am S1, if you give me any letter or underscore or a digit, I know where I should go. In this case, S1 only. But if you give me a space, I don't know where should I go. Right? So if the machine doesn't know where it should go, then I can say that it is invalid. This is an optimization. I am saving one state. I am not having three states. I am having only two states now. This is called NFA. Why N? Non-determinism, non-deterministic finite automata. So typically you guys will learn about how to draw these machines. When you can draw these machines, you will learn certain languages where you can draw these machines. Certain languages you cannot draw these machines. You need more complicated machines. Machines where you would need to store values intermittently in a stack or something. How to draw those machines. Typically, this is basically what is theory of computation. And you will learn about ways of expressing different expressions. For example, this entire language, you can represent it in a single line like this. Okay. Does anyone know what I have written? Good. So few people have already seen this. This is a regular expression. Why is it called regular? Because two states very easily. So for example, right? Let's build the machine. We have already built it. That's okay. But let's say that you have a machine. You have built a machine where there can be only two characters accepted, which means you either accept an A or accept a B. Okay, you will only read an A or a B, and any string that contains even number of A's should be accepted. Understood what I'm trying to say? Any string that contains an even number of A's, it could contain any number of B's, I don't care. If it contains an even number of A's, then I will accept that string. What do I mean by that? Anyone who can give an example string? Any example? What I'm trying to say? AA, very good, very good. And AABAA, very good, very good. Can anyone give me a counter example? Something which is not valid? ABB, perfect. It has only one A, although two B's it has, but I'm concerned with only even number of A's. Any other example? How about just a B? If I have just a single B, is it a valid or invalid? How many A's does it have? Zero. Zero is a even number. So even B, small b should be accepted. Will empty string be valid here? If I have an empty string, will it be valid? Bilkul. Yes. Even if I have an empty string, it is valid. And in TOC, an empty string is denoted by epsilon. It's just a name of an empty string. Like these guys in set theory say about phi, which is an empty set. Same. Empty string means epsilon. Okay. Don't be like a symbol kahan se aa gaya. Don't worry about that. Epsilon means an empty string. Okay. Okay. Let's draw this machine. And how will you draw this machine? Okay. We always have the initial state that tau is always there. Okay. Okay. What is state S0? State S0 is a state where I haven't read anything. Let's say the string is blank. Nothing. Should it be accepted? Has my machine read anything? Has my machine read anything? Will my machine read anything? Will my machine read any A or B? No, I will stay in S0 always. So I can say that my initial state is also the final state. I have seen an empty string. Empty string means it's accepted. So S0 will be accepted. So I can have only two transitions. I could either take a transition when I read A or take a transition when I read B. Think in this way, okay? This is an empty string which got accepted. If I read a B, should I stay in S0 or go to somewhere else? Think of it in the very simple cases. Think of a single B. If I see a single B, should I stay in S0 or go to some other state? Acha, first of all, let's take a small b. Is it accepted? Is it accepted? So I should stay in S0 because no matter how many b's I read, I hope I can write, yeah. No matter how many B's I read, I stay in the same state. I don't care wherever I go because I am still accepting it. Give me 5 B's, 10 B's, 20 B's, 100 B's, 1000 B's. I will still accept it because I'm only bothered with A's. Now the main thing comes when I read an A. If I read an A, single A, should I stay in S0? First, let's answer that. No, because if I stay in S0, then I will accept it, which is not allowed. Single A should not be accepted. Okay, so I should go somewhere else. S0 will say that, hey, I have read only one A till now, so I can't accept it. Sorry. Can you go to S1? This is if I read a A. One A. Okay. Now it's S1. S1 reads a B. Okay. I have read only a single A and S1 reads a B. Should I go to S0? What if I have? What will happen if I go to S0? Can anyone tell me any string that will be accepted? B will be accepted because I read an A and then a B. I go to S0. So I should stay back in S1. Okay, sure. Okay. What about if I read A? What about if I read A? S2, go to S0. So if I read an A, then what does it mean? I read a single A, I go from S0 to S1, then I read another A. Now my A's have become even, which is accepted. So I will come back to here. Now look at this diagram. If you run through each example that I've written on the right, if any mistake happens, TOC is not the correct. TOC is not incorrect. Okay, that will not happen. Look at AA. From S0, looking at an A, you go to S1. From S1, you look at an A, you go to S0. You land in a final state. How does the machine know that I should accept it? S0 is a double concentric circle. For sure, you can't draw it in the computer. So it sees there's a final state. You can denote it by a single bit, let's say. 1 denotes its final, 0 denotes its non-final. So if it's a final, then you accept it. Look at the second string, double A, B, double A. Again, it should be accepted according to the machine. Yes or no? Right? If it's epsilon, I stay back in S0. Epsilon is again the empty string. But if it is an invalid string, let's say A, B, B, if you look at A, you go to S1. Look at B, you go to stay in S1. You look at B again, you stay in S1. You stay in a non-final state. If you are in non-final state, you can reject the string very easily. Okay. Okay. I hope that gets you more excited about this subject because this is a very fun subject. You will get to learn about drawing these machines and how to draw them in using two states. This is also called a minimal DFA because you can't draw DFA smaller than this one. You might try to draw a bigger DFA. That's okay. Beginners do that. It's okay. You will gradually learn them, and that's what I wanted to talk about in this lecture. We will meet in the actual lectures when it starts from 10th, from the week starting 10th. So if you guys have any questions with what we read till now, feel free to ask. Okay. I open the floor for questions. So there is typically when I was reading about this subject, right? Typically I had this doubt that these machines and all, do they always come in gate? Like, do you need to? Will there be an option as a machine Is there any machine that can take more than one character? What do you mean by it, Rohit? Here is a machine that it is taking more than one character, for example, A and B. Can you give an example? Instead of A taking A. That's a good question, Rohit. Very good question. So you are saying that if my grammar is such that I can only write either two A's or a single B. This one, right, Rohit? So tell me one thing. Okay, let me give you a counter example. If you have, let's say, these two options only to create strings, either you use double A or a single B, will you be able to create this string? Will you be able to create this string? Will you be able to create this string? So do you need a machine to tell that? Do you need to draw a finite state machine which can tell that I have even number of A's? It's if you see this symbol, right? This is in TOC terms, this is called an alphabet, which is the set of symbols that you can use to form the string. So alphabet, if you use this alphabet, let's say, if you use a, you're always bound to use a second A because it's double A. It's not a single A, right? It's a double A. So it's always even. If it's always even, you don't even need a machine to do it. Right, Rohit? Understood what I'm trying to say? Okay, good. So I was saying that typically when I was reading this subject, I typically had this doubt that in the options, will they have this um, machines and all that in the options? Okay. To answer your question, look at GATE 2019 paper, and then let's meet in the final class. Okay. There was a question in GATE 2019. They had not given some states. You had to fill in the blank. Okay. Okay. Dinesh, you would like to give some final thoughts in this, or should we end the call? If you are there. Okay. I think I should stop the.
Yes, Aditya.
Yeah, you
Yeah,
need
so
to.
I think you are done, right?
Yeah, I'm done with my demo class. I'll stop
No
the recording.
problems. Yeah, we can.
Sure. And also maybe I'll send the slides as well. That's okay.
Yeah, you can share the slides in it.
Yeah, I'm trying to just starting and then we'll share in the chat.
Yeah.
Excited about TOC, guys? Now we are not recording also, so I think it's fine. Okay, good. I like the excitement. Yeah, you can find the slides in the chat. Feel free to download and play with it. And we'll meet on Monday.